Hello students, welcome to the interesting chemistry where you will find a feeling of classroom teaching. If you want to enjoy classroom teaching from your study room, then please watch my video of interesting chemistry. Today I am going to discuss with you the shielding or a screening effect, and number 2, the stability of half-filled and full-filled orbitals. So first I am going to explain you what is shielding or what do you mean by word shield or screening. Suppose I am teaching you in your class and if I put my sketch pen in front of my eyes, this sketch pen will create a hindrance to watch you in looking to my vision. So this is called a screening effect. This is called a shielding effect. So now this sketch pen creates a shielding effect or a screening effect to my vision. Now think, where do you find this shielding effect or screening effect? In a small atom. So let's follow me and I will make you understand the shielding or the screening effect in a teeny and is very micro atom. So first of all, I am going to explain you this is the hydrogen. This is the structure of hydrogen atom. There is only one proton and one electron, and this electron is attracted by this nucleus, positively charged nucleus. There is no hindrance, no spinning and no stability, and directly they are attracted to each other. So this electron is stable in the revolving in the hydrogen atom. This is about this single where the atom where is only one electron or the single electron atom. But except hydrogen, all the atoms, all the elements have the multi-electron atoms. So in multi-electron atoms, we see there are so many electrons around the nucleus. There are so many electrons. Each electron is negatively charged. So you know that each electron will repel each other, will repulse each other. So how can these electrons can find stability in the atom? So with this is the electron. So in an atom there are two types of interactions. One is attractive interaction and second one is repulsive interaction. Attractive, each electron, all the electrons are attracted by positive charged nucleus. So this is called the attractive interaction. Now I am adding the word total attractive interaction of all electrons. And the repulsive interaction, this electron repulses to this electron repulses to this. So when the attractive interaction is greater than repulsive interaction, the atom, the electrons may stable. This electron will stable in the atom. Now I am telling you the shielding effect. So it is about the stability of atomic model. I explained you. Now I am coming to the shielding effect. what is shielding effect? Take this example of 2. This is the example of single electron atom. The atom which have only one electron, or the hydrogen atom, and this is the atomic structure of multi-electron atoms. There may be so many electrons, but I have to make you understand, I have selected only one electron in the inner cell, and this is the outer cell. So here in the hydrogen atom, this electron is attracted by this positively charged nucleus, so there is no hindrance, no any other obstacle between the attraction of this positive charge and negatively charged. So it is free of shielding and free of scattering. This is the now. But when you come to the multi-electron atoms, here this is the outer cell electron and these are the inner cell electron. This electron represents the inner cell electron and this electron represents the outer cell electron. So this electron is directly connected to this, but this outer cell electron is being shielded by the inner cell electron to the positively charged electron. So this outer cell electron, due to the presence of inner cell electron, this outer electron doesn't experience the total charge of positively charged nucleus. Now you should say, due to the presence of this inner cell electron, the outer cell electron doesn't experience the total charge of the positively charged nucleus. Hence, due to the presence of this electron, so how much attractive force are developed in this, that is called the net charge. The net charge of in the presence of the inner cell electrons, the net positive nucleus charge experienced by the outer cell electron is called ENC. This is effective nuclear charge, ENC. If anybody asks you, if a question is being asked in your examination, what do you mean by ENC? So you should give this example, because this the inner cell electron is shielding or screening or is creating some hindrance in the direct attraction between the nucleus and the outer cell electron. So this electron will not experience the total positive charge of the nucleus. So the net positive charge experienced by the outer cell electron in presence of the inner cell electron is called as ENC, that is effective nuclear charge, and the effect of this electron is called shielding effect and the screening effect. I think that you have understood about the screening and the shielding effect. So this is whenever you have explained so many fundamentals like the atomic size of the D group elements remain unchanged. Why? Then you will explain with the help of the shielding effect. I will explain you when I will make a video of the size of the D group element, D types of elements. So now I am coming to the second topic, the stability of sp3 and d3 state of orbitals. So it is the orbital stability. Generally, I have explained you in the electronic configuration of my previous video. Then copper had the number of copper, the total number of 29. So we will write 2, 8, and here with 18 and 1. This is the electronic. But when you write the electronic configuration, because here it is the on the basis of the Hund's rule, or the Abbo's principle, the electronic configuration of a copper 29 must be 17 and 2. I can write here 3s2, 3p6, 3d, 9 plus 6 is 17, and 4s2. But one electron is transferred and you will find 3d10 and 4s1. I explained here why it is so. I explained that the full-filled orbital or the half-filled orbitals are more stable. But now I am going to explain you why do the half-filled orbitals and the full-filled orbitals are more stable. So there are two causes. There are 2 points to explain the stability of this half-filled and full-filled orbital. What are the 2 points? One is the symmetrical. One is the symmetrical distribution of electrons. One is the symmetrical distribution of electrons. What do you mean by the symmetrical distribution? Suppose this is D5. These are the 5 electrons of the D. All the 5 electrons are identical in the spin quantum number. So if they are spinning clockwise, all the 5 electrons are spinning in the clockwise. So it is a similarity. It is a similarity in the spinning. So this is a symmetrical form. Now you know symmetry leads to stability. Where there is a symmetry, there is a stability. So it increases the symmetry of this electron, the spinning of the electron is identical, so it increases the stability of the half-filled and the full-filled orbitals. First point. Second point, number 2, exchange energy. Exchange energy. Please write down my hand. I am scribbling energy. Exchange energy. Think about what is exchange energy. Suppose these are this is one. This is this electron. These 5 orbitals of the d subcell are equal in energy. They are equal in energy. These 5 orbitals are equal in energy. Give me the term. The orbitals which are equal in energy, what are they? They are called degenerate orbitals. Here, please write this name. Degenerate orbitals. What are the degenerate orbitals? If a question of half marks is asked in your examination, what are the degenerate orbitals? So you can explain. The orbitals of the same subcell are equal in energy, so they are called degenerate orbitals. Now think about. I have explained they are equal in energy. Now this electron. I am telling you the exchange. What do you mean by exchange? This electron can replace this electron and replace there, and this electron can come here. this electron may replace its electron and this electron may replace this electron. This is called exchange. When there is exchange in the electrons of the similar energy or in the degenerate orbitals, the energy reduces. That is called exchange energy. So if anybody asks you what is exchange energy, in degenerate orbitals electrons exchange with each other. Again, listen to me carefully. In degenerate orbitals, electrons exchange mutually. They replace to each other. With the exchanging of the electrons, some part of energy is released. That is called exchange energy. That is called exchange energy. When the energy of a system, energy of these orbitals are reduced, energy of this is total reduced, the stability will increase. The stability. So due to the exchange energy, the energy reduced, hence the stability of degenerate orbitals will increase. Now think one thing. Now think, where do you find the maximum energy reduced by the exchange of electrons? In the full half filled or the full filled orbital, suppose. So it is how it is partial filled happen here. Only two opportunities, only two possibilities. It can work, so only one exchange is there. Suppose there are three, so this electron may go here. So here is two. But in the partial filled orbital, the possibility of exchanges or exchanging the electron is minimum. But in the half filled or the full filled orbital, the possibility of exchanging the electron is maximum. I will count them, giving the example. Suppose this is the half filled d orbital. This electron may exchange with it. May exchange with it. They exchange with it, and vice versa. These all electrons will come here. So there are 4 times exchanging. 4 times possibility. But here is only this electron, but here no possibility because these are the vacant. So here the possibility of exchange of electron is minimum. So here maximum 4 times. Now come to this one. This electron will exchange with this electron, and this also with this, and this one. So this all the 3 electrons may come here one by one. This is the exchange. So here there are 3 times. 1, 2, 3. There are 3 times. There are 3 possibilities. 3 times possibilities. Here, this electron. Suppose this electron may go here and this go here. So here 2, and this electron now have 1. So here, so total 4, 3, 2, 3, 7, 9, and 10. There are 10 times possibility in the photon. So I have explained you in the half-filled d orbital there are 10 possibilities of exchanging the electron, and in partial filled d orbitals the exchange energy is minimum. The possibility of the exchanging electrons will be minimum. So here in this way, if the possibility of the exchange of the electron is maximum, so the reduction in the energy will be maximum. Hence, the stability will be increased. So, in this way, you can say that the half-filled or the full-filled orbitals are more stable than this was the exchange energy. So first point by that is this is symmetrical distribution, and second one is the exchange energy. I think that you have understood my way of teaching. Please, so that's all for today. Please like my video, share and subscribe it. My videos are for those students who are preparing for IIT for their examination in their village, for the rural area. They have no chance to attend the coaching or any tuition, etc. extra help. My aim is to help those students who are deprived of the coaching centers and etc. So please, if you know any your friend who is preparing their studies from the rural area, from their hometown, from their villages, so please tell them, share with them. I think some help will be, with my video will help them something. So that's all for today. Thank you for watching. Thank you.